Next presenter will be Dr. David Chambers. David Chambers is the founder and president of the Center for Science and Public Participation. It's a nonprofit corporation formed to provide technical assistance on mining and water quality to public interest groups and tribal governments. Dr. Chambers has 45 years of experience in mineral exploration and development, 15 years of technical and management experience in mineral exploration industry, and for the past 30 years, he's served as an advisor on the environmental effects of mining projects, both nationally and internationally. He has a professional engineering degree in physics from the Colorado School of Mines, a Master of Science degree in geophysics from the University of California at Berkeley, and is a registered professional geophysicist in California. Dr. Chambers received his PhD in environmental planning at Berkeley. His recent research focuses on tailings dam failures and the intersection of science and technology with public policy and natural resource management, financial assurance for mine closure and post-closure, and the water impacts of mining. Dr. Chambers, welcome. Thank you so much for being part of this evening, and go ahead.
Thanks very much for the introduction, Greg. And again, my name is Dave Chambers. I'm talking to you from Bozeman, Montana, where we're forecast to be 35 below zero at this time tomorrow night. So I'm envious of California temperatures right at the moment. If we could have the first slide, that would be useful. Thank you. So my specialty is not economics, but since our theme tonight is economics, I want to discuss a couple of findings that I made in reviewing two documents, and these findings have economic implications. The first document I'd like to talk about is what's called, as you'll see in the top line there, the technical report on the mine project, which was prepared by Amick Foster Wheeler, dated June 1, 2017. So that report's over 5 years old at this point in time. But these reports, which are called NI 43101, NI is National Instrument 43, Section 101. And this is a requirement that's mandated by the Canadian Stock Exchange. So if the company is listed on the Canadian Stock Exchange, it has to provide these documents. And these technical reports are required whenever there's a substantial change in the nature of a project. So the fact that there hasn't been an updated report for 5 years basically says the fundamental basics of the project are still the same, because this is the official technical report for the project. These reports are prepared by what are called qualified persons, that is, people that are not only knowledgeable in their field of analysis, and there's typically half a dozen or so that are involved with preparing each of these reports, but these people have to put their professional reputation behind their findings. So what I've listed down below the first couple lines are a number of sections, 9, 15, 16, etc. And each of these sections in a technical report, which is sometimes called a preliminary economic assessment, although this technical report doesn't qualify as a PEA because it doesn't contain enough economic information to put it over that threshold. But these sections normally contain a lot of information about the development that's going to take place. And I generally go to these because sometimes I can get information that doesn't even appear in an environmental impact review. So they're generally pretty informative. But the thing I wanted to point out was that under each of these headings, there's virtually no information. What I have literally done is take all of the verbiage that was provided under that section and put it on this page. So for instance, for exploration, the report says RISE has not completed an exploration work program on the property. And I think that's still true. Mineral reserve estimates. There are no mineral reserve estimates for the project. Mining methods, recovery methods, not applicable to the current status because there isn't enough information. Project infrastructure, market studies, environmental studies, capital and operating costs, economic analysis. There just isn't enough information for those experts to provide any even detail on those sections. And this is, I quite frankly have never seen that in a technical report, that lack of information. Let's go to the next slide because I want to talk about mineral reserve estimates a little bit. There is no mineral reserve estimate for this project. So what is a mineral reserve? This diagram is a bit complicated. I will admit more complicated than it needs to be. The diagram itself, the reason I use this one is because it comes from the International Council on Mining and Metals, which is the industry association internationally. So it's a very well accepted source. And under the word exploration results on the top, you'll see two categories: mineral resources and mineral reserves. And what you need to have if you're going to have really a viable mine proposal is to have some sort of mineral reserve identified, because that establishes the amount of ore and the amount of metal that you hope to recover from this project. So most projects will have a mineral reserve. Down below the mineral reserve, you'll see probable and proved. Those two categories are generally lumped together. So a mineral reserve is defined as probable and proved ore. A mineral resource, on the other hand, isn't as well defined. It can be measured and indicated, or the weakest category is inferred. And in most economic analysis, measured and indicated are lumped together, and then inferred is a third separate major category. So a probable and proven mineral reserve is a mineral reserve that's been drilled out to a drill hole density such that you have a very good idea of what sort of ore is contained in that defined ore body. Indicated and measured, that's usually a category that means your drill spacing is such that you have a decent idea, but not enough to really call it a mineral resource. And then the inferred category means you've probably got a few drill holes, you know there's something down there, but you don't really know how much. So the important thing about this whole discussion is that Idaho-Maryland doesn't have a mineral resource or a mineral reserve. And again, that's just highly unusual for a project to be asking for a production permit without having a mineral resource defined. I don't think, quite frankly, I've ever seen that, but there's no law, there's no rule that says you have to have it. It's just highly unusual. The second document I'd like to talk about is the environmental impact report. I reviewed the draft report, which is dated December 2021. And of course, the final has just come out a year later. And there are three things that I want to touch on that come out of this EIR that have economic implications. The first is waste disposal. The mine plan says that the waste rock that comes out of this mine, that is the rock that's not ore, is going to be either disposed of on the site or used and sold as what's called engineered fill, which is stuff like road fill or foundation material. I think that's a problem because in general, trying to sell mine waste, even if it's technically clean, is still a tough thing to do because there's still potential liability with rock that contains mineralized material, even if it's very low concentrations. And someone who buys that and uses it could potentially run into some liability down the line. So my experience has been that most buyers are just very reluctant to buy that sort of rock when they can get verifiably clean sources like sand and gravel elsewhere. Now, the other sort of potential problem with this engineered fill material being sold, that is the mine waste being sold, is that you do have to test it and prove to the best of your ability that it's not contaminated. And that, of course, is done by taking a representative sample and testing that. We don't know at the present time what the exact geochemistry of that rock is going to be. It would, of course, have to be sampled as it comes out of the ground according to some protocol, which has yet to be established. Right now, I'm questioning the geochemical characterization of the waste rock that's taken place. The EIR says there's going to be about 2 million tons of waste rock produced in the first 11 years of mining. And to the best of my ability to look at the samples that were used to make that analysis, that analysis comes from 2 samples that come from a total of 11 feet of drill core. So that's a very small sample to represent a lot of tonnage of material. It does not meet the widely accepted recommendation for the number of samples. So I just think that geochemical characterization has to be preliminary at this point in time. There are significant planning gaps associated with the material provided for the EIR. There's no existing monitoring plan, although there are promises to produce one. There's no waste characterization plan, which is the plan that you would use to test the protocols that you would use to test the waste rock. Normally that material would be provided as a part of an EIR so that people like me can say, this is where things are going to be sampled, say for surface water or groundwater. And these are the constituents that are going to be sampled. All of that is important and none of it's available in the EIR at present. And then in terms of the waste characterization, again, I don't think the waste rock is adequate. The tailings, the characterization I have questions about. That characterization for the tailings is based on only 4 samples, 4 samples that are physically different in size. So they're going to produce different leaching results, probably just because of the size when they're tested. And the reason you leach, essentially drain water through this material, is you want to see what the water picks up when it comes out. The tailings for this mine were tested using distilled water. Now rainwater, which is what is really going to be moving through this material when it's placed on the surface, isn't distilled water. It typically has a lower pH. It has more ability to leach metals out of material on the surface. And most testing that's done for mines is of this kind is done using a weak acid solution instead of distilled water. So again, there are no hard and fast rules about how this testing must be done, but the testing protocol that was used for the tailings and waste rock and the EIR is not typical of what I would see in that sort of a document. And then finally, financial assurance is something that I've spent a lot of time with over the years. The company has asked Nevada County to issue a permit to mine for 80 years. And yet I don't believe that the information that's been supplied in the EIR is sufficient to justify a permit to mine for that length of time. In fact, this is really, this project is at a very post preliminary exploration stage. It's not a production project. There's no mineral resource. And the first step is to go down and find out what you've got down there. That would involve dewatering the mine and doing drilling from underground. And that's going to have to take place inevitably, but you don't need to grant a project, a production permit in order to do that. Now, I don't know of any mine that I've ever reviewed who's been given a permit for 80 years. I can think of one or two for 20, but when you ask for a permit of that type, you generally have to provide plans that say what you're going to do for that entire period of time, how much waste you're going to produce, where that waste is going to go, and of course, how you're going to close that project out. And much of that information is still lacking. Part of a closure plan, and I'm sure this is true in California, is to provide a financial assurance. These financial assurances are important because even for a mine like this one, that would be tens of millions of dollars. And in some cases, it could be hundreds of millions of dollars. I think the largest, actually, I'm aware of two of them that have financial assurances that are over 500 million. Those are for large mines. This isn't a large mine, but it just shows you the magnitude it can go to. And that number tends to get very big if there's long-term water treatment involved. This mine is not predicted to have long-term water treatment, but I'm not very comfortable about the predictions that have been made that support that prediction. So I think it's still an issue. And basically, if a permit is issued for a mine for that length of time, then that regulator has to say that if this mine closes down for any reason, we're going to have enough money on hand at any point in time to close that mine properly so that it doesn't have environmental and economic impacts on the community that it's in. And in order to establish that financial assurance, you need a lot of information that just isn't available at this point in time. So if I were a regulator, I would be very uncomfortable at this point granting a permit for a mine and trying to establish an adequate financial assurance, a financial assurance that would protect the public, based on the information that's available. And then just one final word on financial assurances. Even though they're typically required for every large mine in the US, and this is a state-by-state requirement in large part, those financial assurances never cover anything but what I want to call reasonably foreseeable conditions. So if you were to have something like a tailings dam failure or some other catastrophic environmental event, that financial assurance is not made to cover those sort of accidents. So just because you have a financial assurance, that doesn't mean that you're totally covered as a nearby community. So I'm going to stop there. I'd be glad to take questions when the time comes, but Greg, I'll turn it back to you. Thank you.